what I'm doing is working backwards from an existing running instance of Hyperledger Fabric in the test environment with showing our test code running. And then I'll walk backwards to actually showing the source of it, that type of thing. And so basically it's finished product, finished system, going backwards. This worked better as a demo rather than going forward. Okay, so on the top right is a window that's in the what's called the first network, which is a test environment in the Fabric samples. And in it, normally it sets up and does a test run that just runs a piece of common chain code that they've sent up, improves everything works. What I did instead was modified it so it just comes up, sets up the environment, and sits there. And so it's running. So what it does, it creates a bunch of Docker images, Docker containers rather, from Docker images. And I'll show that to you in a minute, if I can get it to slide over. Come on. So this is the list of Docker images, Docker containers, and here they are running. I just listed them again with a Docker PS, and you'll see that there's the CLI right here, means command line interface, and then this is orderers and peers. So the peer nodes are the things that you're actually talking to that from your client applications that you send transactions to and queries to. Somebody needs to mute. I hear background street noise. Okay. You'll see that there's several of these. So what will happen is in an organization, it's common to have more than one peer. So I have a peer 0 organization 1. I have a peer 1 organization 1. Then I have a peer 1. I'm sorry. Then I have a peer 0 organization 2. And a peer 0, there's another peer 0 peer 1 organization 2 lying around. The orderers are the consensus algorithms. And right now I believe it's all defaulted over to Raft. And then these are the commands that are sent. Peer node starts the node. Orderer, I don't know why they didn't say orderer start, but it should say orderer start, but it's just orderer, and it runs. And they're up and running. Over on the top left, I'm actually in the command line interface container right now, the CLI. And to see that, I'm just going to pop out and back in. I'm going to exit from it. And I'm going to go back in. This will just exec a bash in it. And it's up there. Okay. The bottom left is actually in the peer container. I'm actually in peer0.org1, I think, .example.com, because I have a log file for the code that I've created. So this is the directory for an external builder. You'll see the word external builder right here, which I'm using for the Hyperledger version 2.0. And I'm running, this is what it thinks is running its chain code, which is actually our class manager infrastructure. And then what do we have also? Our class implementation files. This is the meta class, and this is a root object, class object. And so what happens is the class manager gets brought up as though it's regular chain code, and then it's loading these in as Go plugins. And the idea, obviously, you can load as many, you load classes and you inherit from them. They actually look like separate plugins. The reason, the other key line here is the log file. The version 2.0 deprecated the shim layer own log file and said write your own. So I wrote my own. It's called in this class manager log. And what I'm going to do is tail it so you can see it running. So that's what's going on. I will run it. And then over on the far right bottom is just I'm just logged into my home directory, and I have created a little file that has in it a command that I want to run. And so this is how you do it from the command line. You normally use an SDK, but from the command line, if you want to invoke something on a transaction and chain code, you would say peer chain code invoke, and then you would say what orderer you're using, a bunch of TLS related issues and certificates, It goes down through this, you can see all of them. It tells you what channel you're on here. I created mine as classically named my channel. And what it thinks is the class manager code, is a chain code rather, is called class manager, which is for us actually the class manager infrastructure invoked a message. This is what peer you want the client to connect to do the transaction. It's sitting here, it goes all the way through. It actually does two of them because it asks for the invocation on two different peers to get two different endorsements. And then what it's actually asking it to do is way down here. This is the actual transaction. Say so -C, and then it says args, and then here's the actual argument done up as a message. So it's object send to an account, to an object in the account, in this case it's class, to the message that it wants it to execute, which happens to be message test. And then this is JSON syntax of the input arguments. So imagine that I had an input argument structure with a bunch of different fields. This would be on the left side is the field name, on the right side the field value. And of course you'd want it to be, if it's integer, you want it to be an integer rather than a string or something like that. All I'm going to do, this is the easy part, is go, hey, I'm going to cut and paste it. Copy over here, run it over here. Come on. Hello, give me the, there's the paste. And I'm going to run it. And you'll see that the screen, this was the, down on the bottom, it actually did the run. It did the, wrote to the log file. On the top, this is the actual transaction result. And this actually went through a full invocation, which actually, I believe, does the entire part that sends out updates to the distributed ledger as well. So this is the, because using the command line invoke does that. Hang on. You notice that in the result, I have the result returning as JSON syntax as well. And again, if you knew that the out arguments had a field test out string, which I actually have, that's what the structure has in it. And then the rest of this is I just literally copied this in. It says message. If you looked at the actual result of the message, I'll show you that code. It literally puts in the word message test result : test out string. There's nothing special to it. Excuse me. That's literally just so that you know it. That's doing. Down below is the actual run of the code, which we can walk through the code afterwards. This is entering invoke is the entry point to all chain code, including the class manager. So I have a piece of code that handles invoke. And then it turns it immediately and says, are you doing an object send? Yes, okay, I'll run you over to do transaction, which is the implementation for it. Gets the object name, the class name. So here's the object, the object name and the account name. Here's the object name sending message to. Here's the account that it's in. And the concept of this is that we're creating in the class application framework for the XBOM that you have root account objects. So each account has a root object, and all the other objects are contained within it. And that includes, by the way, classes, because they're objects as well. So, excuse me, a class can be in an account as well. This is just saying I'm going to the distributed ledger to go get the object. This tells me I'm going to go get the class for the object. Now notice that right now I'm using an actual string name for the object in the account. These could just as easily be SHA-256, bit strings instead. There's nothing specific to them being a name, and in fact they're being used as though they are actual ledger key values right now. I just made them printable, and we'll make a handful of them reasonably printable. Human readable, rather, is right words. Here's the input arguments. So this is part of the message that it received. It's going to do an object send. So an object send means I can send a message to an object in an account where I'm outside of that account. Object call would mean that I'm inside the account. So think of it as processes. I'm inside one process. Wow, somebody needs to mute. Okay, inside an account, you'd want to do a call between objects in the account without crossing account contexts, which is similar to processing process context, but not exactly the same. Here it's just saying the code for object sends doing the method call. It got out of it okay. This is part of where I'm doing the marshalling of the JSON syntax. Technically, the call to JSON marshal should be the argument type, which would be test out args type, not a pointer to test out args type, but it handled it that way, so I left it at that. Here's the result. So I print this out internally for the log, then I exit do transaction, exit invoke, and as I'm exiting invoke, this is the success from shim.success. That works, and you see it again up here in the status payload result. So that's the actual full run of the system.